Hello, today we're going to do 5.3, which is standard deviation. So in statistics, dispersion, also called variability, scatter, or spread, is the extent to which a distribution of data is stretched or squeezed. Standard deviation is a measure of how scattered the data values are in relation to the mean. It's always positive as it measures distance. So let's write these notes down, please. Low standard deviation value equals the most data values are close to the mean. So it's consistent and not spread out. So that looks like, if we have the mean here, right? So our mean, most of our data is going to be close to the mean, right? That's what that's saying. So it's not very spread out and it's close to the mean. Okay, so everything is close to the middle, the mean. But a high standard deviation is the data values are scattered farther from the mean. So it's inconsistent and spread out. So if our mean is here, so mu is here, that means like our data values are pretty spread out and not centered. So do you see that? How it's different. So the mean on the first one here for a low standard deviation, all the data points is centered around the mean, but for a high standard deviation, they're spread out. Okay? All right, so the standard deviation, sigma, can be expressed using symbols. So this is the formula. So please write down this formula. So it is sigma equals the square root of the summation of x subtract mu squared divided by n. Now I know that's just a bunch of messed up letters, but these symbols are explained here. Okay, so n is the population, so the number of data pieces. X is each data piece. Mu is the mean, and the weird looking E means summation, so the total. Okay, so have this formula copied down in your notes, and it would be a good idea to have all these explanations as well. So what does that formula mean? Because that is a mess of stuff. So first, how we're going to calculate this is we need to know the mean. So we know how to get the mean from a few days back, right? So we add up all our data and divide by how many numbers there were. Then number 2, we're going to find the difference between each data value and the mean. Then 3, we're going to square all the differences and add them together. 4, then we're going to divide by the number of pieces of data. And then 5, you're going to take the square root of that number, and this is the standard deviation, or the sigma. Okay, so these problems are very long and tedious. There's a lot of work that goes into them, okay? All right, let's try our first example. Example number 1, find the mean and standard deviation for the prices in dollars of video games at an electronics store to the nearest dollar. All right, so over here, this is our data. Okay, so let's write down this data. And our first step, if you remember from last slide, is to calculate the mean. Okay, so add up all these numbers. You should get 372 and count how many data there is, and there's 6. That equals 62. All right, then you need to set up a table. You only need it to be 4 across, okay, and you'll need it to be 6 down. So you're going to label it data or number, which is our x, mean, which is mu, difference, which is the deviation, x subtract mu, and then deviation squared, so x subtract mu, then square. So see, this has all of our steps except the last one. Okay, so we're going to calculate the standard deviation. All right, let's look at the first one. So our first data point is 45, so you fill that in. We know the mean, so the mean is going to be the same for each of these numbers, or each of these columns, okay, so 62. Then we take x subtract mu, so 45 subtract 62 is negative 17. Okay, and then the last column, you're going to do negative 17 squared, and that's 289. All right, our next data is going to be 56, right? So fill that in. 56, 62, then 56 subtract 62 is -6. -6 squared is 36. So now I want you to fill in the rest of the columns with each of these data sets, okay? All right, and then at the end, you need to add all of them up, okay? So 372, 372, 0, and then we get a total here of 690. So add up all of that information. So, sorry. Now we're calculating our sigma, right? Our standard deviation. So our sigma is 690 divided by 6, right? Because we've already calculated this, the summation of x minus mu squared. That's the 690. In n, we know there's 6 data points. So 690 divided by 6 equals 115. And square root that, and you should get 10.7. Okay? Let's do another example. Example number 2. Calculate the mean and standard deviation for the points scored by Jamal Murray in each game versus the LA Clippers. All right, so let's get our data and our mean. So here are our test scores. And then our first step is to calculate the mean, right? So add up all these numbers, divide by how many numbers there are, so 22.57. All right, now let's make a table just like we did. So number, mean, deviation, and deviation squared. So our numbers, just put all of our data sets in here, right? Add them up. And our mean, we know our mean, it's all going to be the same thing, right? All right, now from here, you should be able to calculate the deviation. So 12 subtract 22.57 is going to give us our deviation here. So negative 10.57. And then square this number in your calculator, you should get 111.72. Okay, so let's keep going. So 27 subtract 22.57 is 4.43. Square that, get 19.62. All right. So please do these in your calculator. Add them all up. So we have our 543.68 as our total summation, right? So our summation of our deviation squared. So now we're going to calculate our sigma, right? So our sigma, we know we're going to put 543.68 over how many numbers there were, so 7, and square root that. So divide those two numbers and square root it. 77.66. And lastly, get that number for me, 8.8. Okay? Hopefully this makes a little sense. So now you're going to use all this, so make a chart, okay? The chart will really help you simplify this, and you're going to work on, I forget how many questions, but there's a few questions on here to calculate standard deviation, okay? Good luck.